share something interesting that I have read in article about application powder metallurgy in cars automotive. Do you guys want to know about it?
Yes.
So first, powder metallurgy is a manufacturing process that uses metal powder to produce finished component. It is versatile and cost-effective process that is well suited for the production of a wide variety of automotive component. So, how the powder metallurgy process in car application typically involve. So, metal powder is produced by melting metal and then breaking it up into tiny pieces, and then the metal powder is mixed with other gradient to make it easier to shape and become stronger. So the metal powder mixture is pressed into a mold to give it the desired shape, and lastly, the molded metal powder is heated to bond the particle together, and the finished part may be machined or coated to improve its properties. So the powder metallurgy have its own advantage in car automotive. So the advantage is it can make the near net shape of the product, a high strength and density of the car part. Complex shape can be done, like rotor, gear, brake pad, and something else. And it is a cost efficiency process, so you can save your own money by using this production. So as the automotive industry continue to move forward, powder metallurgy is expected to play an increasingly important role in the production of automotive component. You guys understand what I'm trying to say?
Yes, absolutely.
So you guys have a question to ask?
No, we are clear about it.
So if you don't have any question, can I ask you how the application of aerospace in powder metallurgy? SUWETHA?
As SHAQEEM did some research, I also have done some research regarding aerospace. Well, powder metallurgy is extensively used in aerospace industry due to its ability to produce parts with complex geometries, high precision, and specific material properties. The application of powder metallurgy in aerospace, including the production of aircraft, helicopters, and spacecraft, are similar to those the automotive industry. There are some key applications of powder metallurgy in the aerospace sector. First of all, engine components. Just like in the automotive industry, powder metallurgy is used to manufacture various engine parts in aerospace, including turbine, disc, compressor parts, scarves, and gears. These parts demand high strength, temperature resistance, and precise tolerance which powder metallurgy can provide. Next, structural components. Powder metallurgy is employed to fabricate various structural components in aircraft and spacecraft, including brackets, fittings, and fasteners. These parts require high strength, durability, and often intricate design that powder metallurgy can produce efficiently. Thirdly, landing gear components. Some parts of the landing gear assembly, such as bushings, bearings, and brakes, can be manufactured using powder metallurgy. Powder metallurgy provides parts with excellent wear resistance and strength, crucial for safe and reliable operation. Last but not least, environmental control system components. Powder metallurgy is used for parts in environmental control systems such as valves, fittings, and connectors. These components often require corrosion resistant and specific material properties that powder metallurgy can offer. So, in aerospace, there are some advantages of powder metallurgy where aerospace application align closely with those in automotive industry, including cost effectiveness, the ability to produce complex shape, high precision, and tailored material properties. Additionally, powder metallurgy's capability to produce lightweight components is particularly valuable in aerospace, contributing to weight reduction and fuel efficiency in aircraft. However, in aerospace, there might be even more strict requirements for material performance, reliability, and safety standards, which necessitate extensive testing and certification process for powder metallurgy produced parts in the industry. Also, in high performance or extreme conditions, the limitations of certain materials or limitation on part size and complexity might need consideration. So, do you guys have any question?
Thank you. No,
I am absolutely clear about what you explained about.
yes, it's very detailed and very good explanation.
So, I heard about RIYADH also done some research regarding jewelry. Can I know about your research?
Absolutely yes, because today's work, powder metallurgy is quite wide, especially in consumer goods such as jewelry and others material. Jewelries in powder metallurgy can give advantages in our society. My first advantage that I seen a lot in this world is powder metallurgy can give a complex shape and intricate shape about diamond processing, such as jewelry and so on. Number two, there is less waste material than with traditional casting processes. The process is more environmentally friendly. A wider range of alloys can be used. Component can be made with a uniform microstructure. The powder metallurgy processes for jewelry making typically involve the following steps. The first one is powder preparation. The powder is the first process is necessary to clean contaminants and other impurities. We must clean the metal by cleaning and drying it. Second step is mixing and blending. The powder is mixed with other materials such as binder and lubricants to improve its flowability and compressibility. Number three, compacting process. The jewelry is in making by powder mixture is compacted into the desired shape using a press. The second last one is sintering. Compacted part is heated to a temperature just below the melting point of the metal. This causes the powder particles to bond together, forming a solid part. And the last one is finishing. This step is quite important and necessary because jewelry is quite observed by the fans about it. The sintered part is finished to the desired specification. This may involve machining, polishing, or plating. I think that's all I can tell about the benefit and processes in powder metallurgy of jewelry. I may ask you, ASYIQIN, about what is your powder metallurgy application on what field?
Thank you. I have do research about the oil and gas industry. Powder metallurgy plays a significant role in the oil and gas industry, primarily in the manufacturing of components and parts for various applications. Here is an example in which powder metallurgy is used in the oil and gas sector, which is MIM, metal injection molding. MIM is a powder metallurgy process used to produce complex near-net shapes components. In the oil and gas industry, MIM is used to manufacture small intricate parts like valve, components and sensor housing, which needs to withstand with environmental condition, which can be especially important for offshore installation and transportation. Powder metallurgy offers advantage such as high material purity, fine-grained structures, and the ability to create complex shapes, making it a valuable manufacturing method in the oil and gas industry, where components often need to withstand extreme conditions and provide high performance and reliability. While powder metallurgy offers several advantages in the oil and gas industry, it also has some disadvantages and limitations such as limited size and geometry, high cost, dimensional tolerance, and waste energy. Despite this disadvantage, powder metallurgy remains a valuable manufacturing method in the oil and gas industry, especially for specific application where it is advantage like just now I told you guys. Careful consideration of the specific requirements and cost effectiveness is essential when choosing this method for oil and gas components. That's all from me, I think. Thank you.
So, after all the research and application that can be used in powder metallurgy, I can make a conclusion that powder metallurgy can play a pivotal role in producing high quality, cost effective, and precise component that contribute to the performance of application that we use. So I think powder metallurgy is very good in this day to be used because with the economy is getting higher and higher, the cost of powder metallurgy is very low and effective, so we can save our money and have a very good product. So that's it. Thank you.